Look at modern bridges, built with laser precision, titanium reinforcements, supercomputers, and billion-dollar budgets. Yet, many of them will face structural failure within just 50 to 100 years. Now look at this. 516 meters of solid sandstone. No modern machinery, no steel rebar, no digital physics simulations. Just human hands, oak, and rock. It has stood directly in the crosshairs of one of Europe's most violent rivers for over 6 centuries. It survived the 30 Years' War, the relentless bombardment of invading armies, and catastrophic floods that wiped modern concrete structures off the map. How? What did 14th century masons know about engineering that we have forgotten? The secret hidden beneath these dark waters is so complex, so terrifyingly dangerous to build, that modern engineers admit they would struggle to replicate it today, even with modern technology. It is the year 1357. The Vltava River is a monster. It's not just a body of water, it's a terrifying force of nature that has already destroyed the previous crossing, the Judith Bridge, tearing its stone piers apart like they were made of sand. Emperor Charles IV, the most powerful man in Europe, faces an impossible crisis. He needs a bridge to connect the two halves of Prague, to control the trade routes of an entire continent. But you cannot simply drop stones into a raging, freezing river and expect them to stay. To conquer the river, they had to fight it. And to fight it, they needed to build something that sounds utterly insane for the Middle Ages. A dry workspace, 3 meters underwater. They called it the cofferdam. Yeah, and it is a masterclass in survival engineering. Imagine standing on a wooden barge in freezing, rapid waters. Surveyors, using nothing but ropes, sunlight, and primitive geometry, mark the locations for 15 massive piers. The tolerances? Measured in finger widths, across 500 meters of open water. If they are off by a fraction of a degree, the river's current will eventually tear the arches apart. Pile drivers? Massive wooden rigs powered entirely by human muscle and gravity, pound 8-meter-long solid oak stakes directly into the rocky riverbed. Thud, 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 day and night. They don't just build one ring of oak, they build 2 concentric circles. 64 massive logs per ring. Between these 2 wooden walls there is a gap, exactly 1 meter wide. And here is where the medieval genius shines. And they didn't have waterproof concrete, so they used the river against itself. They packed that 1 meter gap with heavy, dense river clay, ramming it down until it formed an impenetrable seal. The Vltava was literally walled out, but the dam is still full of water. Enter the water wheels. Relentless, continuous pumps powered by the river's own current, drawing the water out of the dam. Slowly, the water level drops. 3 meters below the surface of a raging river, laborers step onto dry mud. If that clay seal breaks, the river rushes back in, and everyone inside the dam drowns instantly. This was the reality of 14th century construction. Yet before we uncover what they buried beneath the riverbed, a secret so durable it defied time itself, make sure to hit that subscribe button and join us as we reverse engineer history's greatest mega projects. Down in the muddy, terrifying depths of the cofferdam, the real work begins. You can't just stack stones on mud. The weight of the bridge would cause it to sink and snap. They needed to anchor the bridge into the Earth's very bedrock. They drove a precise grid of foundation piles deep into the stable ground. But wood rots in water, right? Actually, no. When oak is driven completely underground, cut off from oxygen, the bacteria that cause decay cannot survive. The wood essentially petrifies. It becomes as hard as iron. On top of these petrified underground forests, they laid interlocking oak beams, creating a massive grid. They packed river stones into the timber framework, creating a composite foundation of incredible strength. Then came the raw iron. Blacksmiths forged massive iron clamps, heating them until they glowed bright orange, wrapping them around the giant foundation stones and sealing the joints with molten lead. This wasn't just building a wall. This was forging an unbreakable, solid mass of armor against the water. 8 by 24 meters of hidden engineering supporting everything above. And they did this 15 times, simultaneously. But a bridge is only as strong as the mortar that binds it. And this is where the Charles Bridge crosses from engineering into legend. For centuries, rumors whispered that the master builders mixed raw eggs, milk, and wine into the lime mortar to make it stronger. It sounds like a myth, but a romantic fairy tale told to tourists. But recently, modern chemical analysis was performed on the original 14th century mortar. The results? They found organic proteins. The legend is true. The medieval builders intentionally used organic additives, creating a biological chemical bond that cures slower, but hardens into a material literally stronger than the sandstone blocks it holds together. Now the piers begin to rise. But notice their shape. They aren't square. They are shaped like the prow of a battleship. These are the ice guards. The builders knew the river would freeze, and when spring arrived, millions of tons of jagged ice would rush downstream like artillery shells. The pointed piers were designed to slice the ice in half, deflecting the catastrophic impacts safely through the arches. Ah, the arches. Type the ultimate test of gravity. To span the 20-meter gap between the piers, you have to build in thin air. Carpenters constructed massive wooden falsework, temporary timber bridges spanning the gaps. Master stonecutters extracted blocks weighing over a ton each from Bohemian quarries 20 kilometers away. Oxen dragged them. Barges floated them. Every single stone in the arch, called a voussoir, was cut to a unique, microscopic angle. They are wedge-shaped. They don't stick together because of glue. They hold together because of gravity. They built from both sides simultaneously, creeping closer and closer over the open water. Then comes the most dangerous, terrifying moment of the entire 45-year project. The keystone. The gap narrows, the compression builds. The massive stones are desperate to fall, are held up only by the groaning wooden falsework below. The master mason guides the final, perfectly carved keystone into the exact center. As it descends and locks into place, the physics of the bridge instantly transform. The crushing downward weight of gravity is suddenly redirected. It flows horizontally outward, through the wedges, down into the massive piers, and deep into the petrified oak beneath the river. When they knocked the wooden falsework away, the arch didn't move a millimeter. It stood by the sheer, unyielding force of compression alone. They repeated this miracle 16 times, 500 meters of unbroken stone, but they weren't done. A bridge that catches rainwater will eventually rot from the inside out. So, they carved hidden drainage channels deep within the masonry, creating a passive system that has protected the bridge's core for 700 years without a single day of maintenance. They crowned it with towers that are masterpieces of Gothic proportions. They added 30 Baroque statues of saints that turned the crossing into an open-air gallery suspended above the water. From 1402 to today, it has never stopped working. Modern engineers have drilled into it, attached digital sensors to it, and scanned it with lasers. Their verdict? The load paths, the exact way the weight flows through the stone, is performing exactly as the 14th century master builder, Peter Parler, calculated in his mind. We look at the past and assume they were primitive. We assume our modern steel and glass represents the peak of human intelligence. But the Charles Bridge stands as a 500-meter monument of pure defiance against that arrogance. It tells us that true engineering isn't about having the most advanced tools. It's about a profound, almost spiritual understanding of materials, of nature, and of time itself. It took 45 years, thousands of craftsmen, millions of stones, built without machines, standing without equal. If you want to see how modern engineers are desperately trying to learn from these ancient masters, hit subscribe and let me know in the comments below. Which impossible ancient megaproject should we investigate next?